Hello, hello, hello! Today we are learning about parallel and perpendicular lines. I imagine you already have a little bit of an idea about what parallel lines look like and what perpendicular lines look like, but we're going to investigate them a little bit further, a little bit into maybe something that you haven't talked about before. Okay, first thing up, I'm going to find the slope of each line. So first I want to find the slope of line A. So here's line A. Remember, I just need to pick 2 points on the line and count my rise over my run. So to get from here to here, what do I rise, what do I run? I rise 1 and I run 2. So line A has a slope of 1/2. Okay, let's look at line B. Line B, I'm going to just pick these 2 points. What do I rise, what do I run? I rise 1, I run 2, so my slope is a 1/2. Let's just look at line A and line B for a second. Notice they have the same slope. And what do these lines look like to you? Think about our title, parallel and perpendicular lines. Line A and line B, they look parallel. These are two lines that will never, ever intersect. So lines A and B are parallel. And notice they had the same slope. Keep that in mind for later. Okay, let's look at the line C and see if we can figure out its slope. I just need to pick 2 points on there. I'm going to pick this one and this one. To get from here to here, what do I fall, what do I run? I fall 2, I run to the right 1. So my slope is -2/1. Okay, let's look at the slope of line D. So line D, I want to pick 2 points on my line. So I'm going to pick these two right here. What do I rise and run? I rise 2, I run 1. So my slope's a +2/1. Okay, so we already talked about lines A and B. Those are parallel lines. Now it's asking us to compare the lines B and C. So here's line B, and here's line C. Think about the title of our section, Parallel and Perpendicular Lines. How do line B and line C look? Do they look parallel? Nope. Do they look perpendicular? They do. They intersect, and perpendicular lines, not only do they intersect, but they have to form 90-degree angles. Now, just eyeballing it, it's hard to know if these are 90-degree angles or not, but I know that they are. So these are perpendicular lines, and I'll tell you why I know. When I look at their slopes, 1/2 and -2/1, these guys right here are called negative reciprocals, or sometimes they're called opposite reciprocals. So 1/2 and -2/1. They're reciprocals. Let me just cover up that little negative. If I flip 1/2 over, I get 2/1. That's what it means to be reciprocals. Take a fraction, flip it over, so they're reciprocals. The reason they're called negative reciprocals or opposite reciprocals is because one is positive and one is negative. That's what it means to be opposites. One to be positive and one to be negative. So if your slopes are ever opposite reciprocals or negative reciprocals, that's when we get perpendicular lines. So I'm just going to use opposite reciprocals. I find that more students like that better than negative reciprocals. But I want you to know both. They're called opposite reciprocals and they're called negative reciprocals. And this is their slope. So slope is opposite reciprocals. Okay, talking about line A and B, they had exactly the same slope, which is why they're parallel. So here I'm just going to write same slope. And it should make sense. Slope is their incline, and if they have the same amount of incline, they should never ever touch. If their incline, if their steepness is the same as one another, they should never touch. Okay, now let's look at lines A and D. Line A is here, and line D is here. Do they look parallel? No. Do they look perpendicular? They intersect, but do these look like 90-degree angles? They don't look like 90-degree angles to me. Now, let's look at the slopes for a second. If I compare the slope of 1/2 to 2/1, these are reciprocals. If I flip 1/2 over, I do get 2/1, but are these numbers opposites? No, they're both positive. So lines A and D, they're just intersecting lines. They're not parallel because they obviously intersect, but they're not perpendicular because they don't form 90-degree angles when they intersect. And I know that for a fact because their slopes aren't opposite reciprocals. Their slopes are just reciprocals. Okay, so far, what I want you to know is that parallel lines have the same slope as one another, and perpendicular lines, their slopes are opposite reciprocals. So I'm going to just break into song real quick. I made up this song a couple years ago. Let me shrink it down a little bit. To the tune of Hickory Dickory Dock. Hickory Dickory Dock, the mouse ran up the clock struck 1, the mouse ran down, Hickory Dickory Dock. Okay, so that's the tune, and it goes like this. Parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. That means flip and switch, hey, that means flip and switch, yeah, flip the fraction, switch the sign, now you've got it. Okay, I'm going to sing it to you one more time, just so you can look at it. Parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. That means flip and switch, hey, that means flip and switch, yeah, flip the fraction, switch the sign, now you've got it. This song tells you everything that we just talked about. It talks about how parallel lines have same slope. It talks about perpendicular lines, their slopes are opposite reciprocals, and then it tells you what that actually means. So we'll talk more about this song as we go along. Okay, I'm going to fill in this chart. Let me zoom it back in a little bit so we can see better. Okay, if the slope is 2/3, if I want to give a slope that's parallel, remember, parallel lines have same slope. So if their lines are going to be parallel, I have to have the same slope as what I'm given. So if this line has a slope of 2/3, a parallel line has to have a slope of 2/3. If a line has a slope of -4, a parallel line has to have a slope of -4. If a line has a slope of -1/4, a parallel line has to have a slope of -1/4. If a line has a slope of 2, a parallel line has to have a slope of 2. If a line has a slope that's undefined, a parallel line has to have a slope that's undefined. And that's because parallel lines have same slope. Anytime lines are parallel, like lines A and B up here, their slopes are going to be exactly the same, which we saw. Line A and line B, their slopes were exactly the same. So if you ever want a parallel line, you need the slopes to be exactly the same as one another. But if I want the line to be perpendicular, I want the slope to be the opposite reciprocal. So parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. And then the song says what to do. That means flip and switch. So I'm going to flip this fraction over, and I'm going to switch the sign. Since this was a positive 2/3, this is going to switch to a -3/2. One of the numbers has to be positive, the other one has to be negative. That means flip and switch. This -4 is understood to be over 1, so if I flip it over, I get 1 over -4, but I need to switch the sign. So if this is a negative number, this one has to be a positive number. Okay, I'm going to flip this one over, and I have to switch the sign. So since this is a negative number, this is going to be a positive number. This 2 here is understood to be over a 1. That means flip and switch. Flip the fraction over, switch the sign. So if this one's positive, this one's negative. So if lines are perpendicular, their slopes are opposite reciprocals. So you want the reciprocal, so flip the fraction over, and you want the opposite sign. Notice this is a positive number, this one's negative. Negative number, positive. Negative number, positive. Positive number, negative. That's what it means to be opposites. One's positive, one's negative. One's negative, one's positive. And reciprocal just means flip the fraction. Okay, now this one we have to think about a little bit. If the slope is undefined, where's the 0? Is the 0 on top or on bottom? The 0's on bottom. It doesn't matter what's up top. I'll just put a 4. Remember, when the 0's under the fraction bar, the slope's undefined, undefined. So if I want a perpendicular line, I flip the fraction, which would be 0 over 4, switch the sign, but you can't have a negative 0 or a positive 0. It's just neutral. So instead of just writing it 0 over 4, I'm going to write it as 0. So if one line has a slope that's undefined, that would be a vertical line. A line perpendicular to it would have a slope of 0, which is your parallel line. Which is your horizontal line. These two lines are perpendicular, which we see all the time when we see our x and our y-axis. The x and y-axis, these are perpendicular lines because x here has a slope of 0 and y here has a slope that's undefined. So horizontal and vertical lines are always perpendicular. Okay, so this is just asking for what we've already talked about. Lines that are parallel have slopes that are the same. Lines that are perpendicular have slopes that are opposite reciprocals. Or we could say negative reciprocals. So parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. Okay, now I'm filling out a different chart. This gives me an equation of a line. I want to give a line that would be parallel to it. So if I want the line to be parallel, do I want the same slope or do I want the slope to be the opposite reciprocal? I want the same slope. So what's the slope of this line? This line has a slope of 4. So if I want it to be parallel, it's got to have the same slope. So I would have to have a 4 for my slope. But I would have a different y-intercept, and it could be anything I wanted. Say a positive 1, a negative 6, a positive 10. It doesn't matter. I'm just going to show you right now, prove to you in the calculator that these lines actually are parallel. If I go to y equals, I'm going to graph my two lines here. So my first one is 4x minus 3, and my other one is 4x plus 1. And if I graph those, you can see for yourself they're parallel. They have the same steepness because they both have the same slope. They're parallel because they never ever intersect. Okay, so if I want lines parallel, I want them to have the same slope, but the y-intercept needs to be something different. And this y-intercept could have been anything I wanted, anything. Just something other than negative 3. Because if the equations look exactly the same, then you would only just see one line. Okay, let's try parallel again. If I want to be parallel, I want to have the same slope as this equation. So if I want the same slope, I'm going to start with the negative 1/8 x, but the y-intercept can be something different. So what's something different than 2? 5. Or whatever you said. Let me just show you this. So a negative 1/8 x plus 2 and a negative 1/8 x plus 5. Let's just look at these. Graph. There's a negative 1/8 x plus 2 and the negative 1/8 x plus 5. You can see they're the same steepness because they both have the same slope, but they're parallel and they have different y-intercepts. Okay, this last one, y equals 7. Remember what the line looks like if it's y equals 7? It's a horizontal line. So if I want a line parallel to it, I just need to figure out some other kind of horizontal line. So maybe y equals 5. So let me just draw a rough sketch of this. If I drew the line y equals 7, I would go up to where my y is 7, and that would be my line y equals 7. If I drew the line y equals 5, I'd go up to where my y is a 5, and that would be the line y equals 5. And you can see that they're parallel. Remember, y equals lines, they only cross the y-axis. Okay, so as far as these equations were concerned, this one I needed it to have a slope of 4, but the y-intercept could have been anything it wanted to be. This one I needed the same slope, but the y-intercept could have been anything I wanted it to be. This one, if it's y equals, I need this one to be y equals, but this could have been any number I wanted it to be. But I want it to be different than the originals. Okay, if I want a line that's perpendicular, I need the slope to be the opposite reciprocal. So, what would the opposite reciprocal be to 4? Remember, 4 is understood to be over 1, so that means flip and switch. Flip the fraction, switch the sign. So my new slope would be a negative 1/4. That would be the perpendicular slope. I just put an x behind it, and then the y-intercept can be anything I want it to be. I don't care what it is. It could even be the same as this one, but I'm going to make it different. I'll just say +2. So as long as these two lines, their slopes are opposite reciprocals, then we're going to see perpendicular lines. Let's just graph it and get a visual. So I'm going to graph the y equals 4x minus 3. And then I'm going to graph the one that I wrote off to the side, which was a negative 1/4 x plus 2. Let's just take a peek at them and see how they look. They kind of look perpendicular. I know they intersect, and these kind of look like 90-degree angles. But I know for certain that they are because my slopes are opposite reciprocals. Okay, if I want another perpendicular, I need the slope to be the opposite reciprocal. So that means flip and switch. If I flip the fraction over and I switch the sign, what do I get? A +8. So my new line would have a slope of a +8. And then the y-intercept can be whatever I want it to be. Let's just say 20. Okay. This bottom one here, if I want a line perpendicular to a y equals line, to a horizontal line, I need it to be a vertical line. So if I want it to be a vertical line, it can be any vertical line I want. This one that I just drew here would have an equation of x equals 1. X equals 1 would be parallel to y equals 7 because all horizontal and all vertical lines are perpendicular. Okay, let's flip the page over and see what we have over on this side. Graphing. This says graph these two lines, label as parallel or perpendicular or neither, and explain. Okay, first equation first. I know it's a diagonal line because of the x and y. Which one's the y-intercept? 4. So I'm going to plot my y-intercept at 4. 1, 2, 3, 4. Just have to make the best we can with this graph. The slope is a negative 1/2, which means to go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Okay, and I'm going to draw that line. Okay, the next one. I know it's diagonal because it's got an x and a y. Which one's the y-intercept? -8. So I'm going to plot my y-intercept down here at -8. And this one's slope is 2 over 1. So slope is rise over run, so that means up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And I can draw that line. Are these lines parallel? No, because they intersect. I also know they're not parallel because they don't have the same slope. So, are these perpendicular? They sure look like it. Let's look. Are these opposite reciprocals? Yes. If you take negative 1/2, flip it over, switch its sign, you get 2 over 1. And vice versa. If I take 2 over 1, flip it over, switch its sign, I get a negative 1/2. These slopes are opposite reciprocals. So my lines here are perpendicular. So I'm going to write the word perpendicular, and then I'm going to show you the symbol for perpendicular. The symbol for perpendicular is an upside down T. These lines are perpendicular, and the reason is because their slopes are opposite reciprocals. So whenever your slopes are opposite reciprocals, you have perpendicular lines. Okay, next one. Okay, I know it's a diagonal line because of the x and y. Which one's the y-intercept? -6. So I go down to -6 on the y-axis and I plot that point. My slope, remember there's a 1 in front of that x, you just don't see it. So my slope's a 1/7, rise over run. So I rise 1 and I run to the right 7. Or I can do the opposite. I can go down 1 and left 7. And I'm going to draw that line. Okay, my next one. I know it's a diagonal line because of the x and y. What's the y-intercept? 0. You don't see the number behind the x, so it's understood to be a 0. My slope is 1/7, rise over run, so I rise 1 and I run to the right 7. Or I can do the opposite. I can go down 1 and left 7. And then I'm going to draw that line. What do these lines look like to you? They sure look parallel. Let's see. Parallel lines have same slope. Do these two lines have the same slope? They sure do. They both have a slope of 1/7. So I know these lines are parallel. There's a symbol for parallel also. It's two straight up and down lines. These lines are parallel, and it's because they have the same slope. Parallel lines have same slope. Okay, and let's go to the third one. All right, I know this first one is not a diagonal line because it doesn't have an x and a y. So I go to where my x is -4. So I go left 4. This line is only going to cross the x-axis. So if it only crosses the x-axis, this is how it looks. All x equals lines are vertical. Okay, the next one. This is not diagonal either because it doesn't have an x and a y. So I'm going to go where my y is a 6. So I go up to where my y is a 6. And the line only crosses the y-axis. So it would have to look like this. All y equal lines are horizontal. And these lines, what do they look like? Perpendicular. I'm just going to use the symbol. And their slopes are opposite reciprocals. One has a slope that's 0. One has a slope that's undefined. And those are opposite reciprocals. So I'm going to go ahead and just write that down. Slopes are opposite reciprocals. Because if one line has a slope of 0, say that's 0/7, and the other one is the opposite reciprocal, 7/0, and I don't change the sign because 0 isn't positive or negative. When the 0 is in the denominator, that's undefined. So the slopes are opposite reciprocals. Okay, I know you're going to turn me off, but I want to sing the song one more time. All right, here we go. Parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. That means flip and switch. Hey, that means flip and switch. Yeah, flip the fraction, switch the sign. Now you've got it. Smiley face.